Okay, 1.8 right triangle applications video lesson. Okay, this is basically when we say right triangle applications, we're really just talking about the good old word problems. Okay, so let's just dive into it. It says draw a picture and work each problem. Round side lengths to the nearest hundredth and angle measures to the nearest degree. Alright, so that's kind of what we're used to already. We'll have to keep that in mind as we work along. So it says a ship is passing a lighthouse. At its closest point to the lighthouse, radar determines that the ship is 2,400 meters from the lighthouse. The ship continues on its path, and at the next measurement, it's 2,650 meters from the lighthouse. And then it's going to ask us a couple of questions. Okay, we really need a picture here, and an aerial view is going to help us the most. Okay, so I'm going to make sure everybody understands what I mean. An aerial view, this means, like, sometimes this is called bird's eye view, where this is the view from the top, as if a plane, you were in a helicopter or a plane looking down on the situation. Okay, so art was not my major, so you're going to have to deal with my drawing. So let's say this is where the ship is. Okay, and it's going in a line. Okay, let's say this is where it's going in this direction. Alright, and at its closest to a lighthouse. Okay, so as it's passing by, let's call a lighthouse right here. We're just going to call it LH. As it's going in this line that it's sailing, okay, the closest is 2,400 meters. Alright, and then it says the ship continues at its path, and at its next measurement, okay, let's just go ahead and put this right here, and I'll darken this ship in, and this will be the ship at the next measurement. It says that we've got a longer distance, which makes sense. 2,650 meters. Okay, so hopefully you can see the right triangle. Let me darken it in black, just to make sure that everybody understands. We've got a right triangle. We know that the hypotenuse is 2,650 and one of the legs is 2,400. Okay, so this is asking us, first, by what angle did the ship's bearing from the lighthouse change? Alright, so we're going to talk much more about bearings later, but this is talking about a bearing from the lighthouse, so it has to be the angle down here. Okay, it cannot be the angle up here. Alright, so what is that angle of rotation? Well, if we just isolate the triangle and forget about the picture for just a second, the rest of the picture, we can find that angle using what we did yesterday, or in the last lesson. Okay, so adjacent to this angle is 2,400, hypotenuse is 2,650, so that's going to lead us to use cosine. So we're going to say that cosine of theta is equal to 2,400 over 2,650. And to find our theta, we're going to take arc cosine of this ratio. Now, it doesn't specifically say this, but when we're talking in problems like this, you want to be in degrees because you want to put your answer. Although technically you could probably be in either. I will tell you though, in all of these, I want to be in degrees. Now, this doesn't equal exactly this angle, but when you type this into your calculator in degrees mode and round to the nearest angle, you will get 25 degrees. Alright, now let's talk about part C. Part C is saying how far did the ship travel. Alright, that's the other leg of the triangle. Now you could use Pythagorean theorem. That'd probably be easiest. You could also use different types of trig functions. I'm going to stick with Pythagorean theorem. 2,400 squared plus x squared equaling to 2,650 squared. You would subtract, take the square root, and when you round to the nearest hundredth, which is 2 decimal places, you would get 1123.61, and let's make sure we put our units on there, which is meters. Alright, let's move on to the next problem. Okay, the picture gets a little bit more complicated, but let's read through the problem and then make sure we understand what all these numbers mean. So this is a person on the edge of a canal. So this is this person. They're looking out to the right. They observe a lamppost on the other side, and they have an angle of elevation of 12 degrees. That's 12 degrees right here. Let me use a different color. That's not going to show up that well. Okay, so this angle right here is 12 degrees to the top, and they also have an angle of depression of 7 degrees to the bottom. Okay? And it says that this person is 152 centimeters high, so I'm going to rewrite that just to make sure that it's easy to see. 152. All right, it's going to ask first, well, what is the width of the canal? Okay, let me go back to green here. The width of the canal is going to be the same as their line of sight if they were not looking up or down, but just looking straight. Okay, so either of these green lines, this is what we're finding in part A. Okay. We can see in these two triangles that the bottom one gives me more information. If I'm looking at, again, let me outline this in black. If I outline this lower triangle in black, I can see that I know an angle. I know that it's a right triangle. And at first it doesn't look like I have either of the sides, but I do. Okay, I know if the person's 152, well, that's the lower part of this light post as well, and I know that their line of sight is X. Okay, I could have also used the triangle here at the bottom, since these are alternate interior angles. All right, either way, according to the 7 degrees, opposite is 152, adjacent is X, so we're going to use tangent. On these types of problems, we frequently use tangent. So tangent of 7 degrees equals 152 over x, and now this is a problem like what we did yesterday. So put this over 1, let's cross multiply. We've got x tangent of 7 equaling to 152, so I would divide by tangent of 7. So my answer is 152 divided by tangent of 7. And so that approximates to 1237.94, let's make sure we got the right units, centimeters, correct. You do not need to change this to meters. You could, it's not necessary though. Alright, let's look at part B. I'm going to switch over here to pink. Alright, find the height of the lamppost. So what they're looking for is, what is the whole height of the lamppost? Well, I already know the bottom section. I really just need to know the top section. So I'm going to put a little y right there, and then when I find out what y is, could have used any letter though, I'm going to add 152. Okay, so let's think about this top triangle. According to 12 degrees, y is the opposite, x is the adjacent, that's another tangent. This time we're doing tangent of 12 degrees equals y over x, which we now know is this 1237.94. Now, to keep your answer extremely accurate, you would not really want to ever retype this number, but you would want to use the second answer feature. Okay, so what I mean is y is going to be approximate to the second answer being 1237.94 times tangent of 12. And so that gives us 415.13 centimeters. Now again, that's not the whole lamppost, it's just the top part, so we need to add 152. I'm sorry, let me back up. I gave away the answer on that one. Some of you typing this in your calculator caught that. So when you do second answer tan 12, you actually get 263.13. That's the top part of the lamppost. And when you add 152 centimeters, the bottom part, you get a total of 415.13 centimeters. And that is the answer to part B, the height of the lamppost. Okay. Next problem. We've got a swimming pool. It's 3 feet deep at the shallow end. The bottom of the pool has a steady downward drop of 12 degrees towards the deep end. Okay, the pool is 50 feet long. How deep is the deep end? For this view, an aerial view will not help here. We need a side view. Okay, so I want you to imagine here is the shallow end of the pool. It's 3. Here is the surface of the water. the pool is going to get deeper and deeper and deeper. And we're assuming it's steady. It says that it's steady, so we're assuming that that's what it means. This 12 degrees is obviously not the angle down here at the lower left. That's an obtuse angle. What the 12 degrees is representing is, let's say the whole pool was 3 feet deep. 12 degrees is that angle of depression right there. It's asking us, the pool is 50 feet long, so we know we've got 50 here. You could also label this dotted line 50. It's asking us how deep is the deep end. Well, we already know that this top part is 3. So the real question is, well, how much further 3 feet deep is it? Okay, so we've got a triangle right here. And I'm using different colors to really show you the different parts of this diagram. You may find this helpful when you're drawing these pictures yourself. Here we have a right triangle. I have 12-degree angle. I have that the adjacent is 50, and what I'm trying to find is the opposite. Now, that's not going to be my final answer, but it's going to be a step. So again, I'm going to use tangent. Tangent of 12 degrees is going to equal x over 50. I put that over 1 and cross multiply. My answer will be x equals 50 tan 12. Alright, again in degrees mode, this whole worksheet in degrees mode. We will get approximately, because we have to round, 10.628. Okay, and this is in feet. Alright, that's just this part, the extension. We need to add 3. And the total depth of the deep end would be 13.628 feet. Be careful when you're doing these problems. Make sure that you're really answering the question that they're asking. Okay, next problem. Penny stands 12 feet from a statue. The angle of elevation from eye level to the top of the statue is 30 degrees, and the angle of depression to the base of the statue is 15 degrees. How tall is the statue? There's no picture drawn here. I want to go back really quick and look at this. This person, when they were looking at the lamppost in problem number 2, very similar picture that we're going to draw here. Okay, so again, my pictures are nothing to write home about. Here's Penny, okay, and she is going to look ahead, and there's going to be a statue. Okay, in my mind, this statue is very abstract, so it's something that looks maybe like something out of Beetlejuice. Okay, so if she's not looking up or down, that there is her line of sight, and here we'll say is the ground. Okay, so they're giving us 2 angles. Okay, they're giving us an angle of elevation to the top is 30 degrees, and they're giving us an angle of depression to the bottom, or to the base of the statue, to be 15 degrees. In both cases, let me just draw a vertical component of the statue. In both cases, I have a right angle. If you're finding these problems really hard, it could be that you're not sure where your right angle is. So I've got 2 right triangles, just like I did in problem 2. And I want to know how tall the statue is. I'm going to have to do this in parts. Okay, so I need to find the top part. I'll call that x. And I need to find the bottom part. I'll call that y. And then to find the total height, we'll add these up. Okay? There's one piece of information I haven't yet labeled on my picture, and that is that she is 12 feet from the statue. So you might be thinking it in terms of here is 12, but I want you to realize her line of sight without looking up or down is also 12. So that gives us a leg in both of these triangles. Okay, let's look at the top triangle. 30 degrees. Opposite is x, adjacent is 12, so that's another tan. Tangent is going to be your best friend in some of these. Okay, so tangent of 30 equals x over 12. Okay, I'm going to go ahead and give you the answer on this. I think you're good about how to solve. Please bring questions in class if you still have them over that part, though. Okay, 6.928 feet. Okay, and to find y, we're going to do something very similar. We're going to take tangent of 15 and that's going to be equal to y over 12. Again, you're going to cross multiply, and your y value is going to be approximately 3.215. All right, add your two components together, 6.928 plus 3.215. Now, adding the unrounded versions of these will give you the most accurate answer, okay? Because I'm going to go ahead and tell you the most accurate answer here is 10.144 feet. And if you think about 8 plus 5 is really going to be a 3 here, the reason this works is because you want to use second answer. If you're not really good with using this, just go ahead and round to 4 decimal places until the very end, round to 3 decimal places. Okay, I don't want you to be too stressed out about this, but this is going to be an ongoing discussion about keeping accuracy as you work through a problem. You could also store the unrounded values in for A or for B, and that's something that I'm going to show you in another lesson. Some of you may already know how to do that, though. All right, let's look at the last problem. A 60-foot drawbridge is 24 feet above water level when it is closed or down. When open, the bridge makes a 33-degree angle with the horizontal. Okay, so what this means is we have this drawbridge. It's open, probably to let ships through. It's 24 feet above water level. Okay, so this distance right here is 24. It says that the drawbridge itself is 60 feet. Okay, so let's label that 60. They have a point P and point Q here, which they're going to refer to in their problems. P would be the tip of the drawbridge, which is going to connect over here. Okay, and Q is the height of the tip of the drawbridge above where it will meet on the other side. Okay, I'm not sure if I explained that the best. The picture really does tell you, though, what these things mean. We have our 33-degree angle with the horizontal, or our angle of elevation, and the first question they're asking us is, how high is the tip P of the open bridge above the water? All right, so they're asking from P to so when the bridge is open, okay, or like this, how high is P above the water? All right, so we've got two distances to consider here, okay? We've got the distance above this line of sight, so to speak, although there's no one really looking, and then we've got our 24 feet, okay? So what we're going to need to do is find from P, okay, to this part, which more specifically would be from Q to the top. We've got to find this first, okay, and then we're going to add it to 24. All right, let's think about how we're going to do that. All right, I'm going to actually erase this because although it's very clear, it's more information than I need. Okay, let me draw this a little bit better. I'm going to put an X here. Once I find X, okay, here to here, I will add that to 24. I'm going to actually close this in so that I can see my triangle. Once you can trace your triangle, the rest is not too bad. Seeing the triangle, though, is the hardest part of these problems. So 33 degrees, the opposite is X, the hypotenuse is 60. So we're going to actually use sine on this one. So sine of 33 degrees equals X over 60. Again, over 1, cross multiply. You get approximately for X 32.678. And I still need to add 24 so I can really get the distance above the water. So I'm going to add 24 to that, and I get 56.678, and our units here are feet. That's the answer to part A. All right, part B, saying, well, when the bridge is open, what is the distance from P to Q? So what is this distance right here? Well, another way to ask this would be, what is this distance down here? Okay, what is the difference between the points directly below Q and directly below P? Okay, look at this rectangle. I have a rectangle down here. And I know now, I know that the height of this is 24. I want to know the width. Okay, I want to know the width, and I want to know, the width up here. So I'm going to put a Y, and this Y that I'm dealing with is just from here and stopping right there. Okay, and once I know that Y, I can subtract it from 60, because 60 is the length of the drawbridge, which would put me, when P goes all the way to right here, 60 would be this width. So it didn't appear that I knew the total width, but I did. It has to be 60, which is the length of the drawbridge. Okay, so I'm going to find the length of the triangle, the missing leg of the triangle, and I'm going to subtract that from 60. Okay, so think about which trig function you need. You really have an option here. I'm going to go ahead and use cosine, so I don't have to use x, which is an approximated value. I'm going to use y and 60. So cosine of 33 is equal to y over 60, adjacent over hypotenuse. Once you cross multiply, you get an approximate value of y to be 50.320, and that is your y value. All right, again, we're trying to find, and I'm going to use the green here, we're trying to find this right there, or P to Q, same thing. So I need to subtract 50.32 from 60. .68 feet. If you were following this lesson but you were getting lost with the actual numbers and the calculations, I would suggest that you go back and rewatch the video 1.6, or that you come in for tutoring so I can help you with the calculator work. Please bring questions to class. Thank you.